Hello and welcome to today's class. So today we'll be dealing on indices. What then is indices? Indices is the plural form of the word index. So indices is the plural form of the word index. Now let's look at index. What is an index? An index is simply the power or degree to which a number or base is being raised. So an index is simply the power or degree to which a number or base is being raised. Take for instance, a multiplied by a multiplied by a multiplied by a multiplied by a. Let's count the number of a's we have here. We have 1, 2, 3, 4, 5. So we have 5 a's, which gives us a raised to power 5. Since we have 5 a's, that means a will be raised to power 5. Where a is the base and then 5 is the index, or you can call it power or degree. Now let's look at the laws of indices. Laws of indices. Starting with the first, we have multiplication law. In this law, if you are to multiply expressions of the same base so that it has same or different index, the main task is to add up the index together. If we are to multiply expressions of the same base such that it has same or different index, the main task is to add up the index together. Take for instance, we have a raised to power 4 multiplied by a raised to power 3. How do we go about this? The first thing is to write down the base. So we have here a, and then the next task is to add up the powers or the index. So we have 4 plus 3, which gives us a raised to power 7. 4 plus 3 is 7. The next one is called the power law. Suppose we have a raised to power 4, close bracket, all raised to power 3. How do we go about it? So we have here a raised to power 4, all raised to power 3. What we do is write down the base, which is a, and then multiply the indices. So we have 4 multiplied by 3, which gives us a raised to power 12. Let's take another example, still on power law. Assuming we have a raised to power m, all raised to power n. How do we solve this using power law? The major and only task is to write down the base. That's the first task. And then the second task is to multiply the indices. So we have here m multiplied by n, which gives us a raised to power m multiplied by n is mn. Now let's look at the third law. which is the division law. Division law states that if you divide two terms of the same base, simply subtract their index or power. Now take for instance, we have a raised to the power 7 divided by a raised to the power 3. The first task is to write down the base. We have similar base, so we have a all raised to the power what? The next task is to subtract their index. So we have 7 and we have 3. So right here 7 minus 3, which gives us a raised to the power 4. 7 minus 3 is 4. Still on the division law, let's take another example. A raised to the power m divided by a raised to the power n. How do we go about this? The first task is to write down the base. So we have a, and then the next task is to subtract their index or power. So we have m minus n. Let's take the third example. 10 raised to the power 6 divided by 10 raised to the power 2. How do we go about this? Now we have similar base. We have 10 here and we have 10 here. So it's similar. The first task is to write down the base. So we have 10, and then the next task is to subtract the index. So we have 6 minus 2, which gives us 10 all raised to the power 6 minus 2 is 4. Now let's look at the fourth law, which is zero law. The zero law states that apart from 0, any number or base raised to the power of 0 is 1. Apart from 0, any number or base raised to the power of 0 is 1. So 2 raised to the power 0 is 1. 1000 raised to the power 0 is 1. Negative 6 raised to the power 0 is 1. 1 all over 2 all raised to the power 0 is 1. Now note this, 0 raised to the power 0 is not 1. 0 raised to the power 0 is not 1. So apart from 0, anything, any number or base raised to the power 0 is 1. Now let's look at the fifth law of indices. So we have here negative index law. Now, whenever a base is raised to a negative index or power, it will be equal to the reciprocal or the inverse of that base raised to the positive form of the power. Let me repeat. Whenever a base is raised to a negative index or power, it will be equal to the reciprocal or the inverse of that base raised to the positive form of the power. Now let's take an example for proper understanding. So we have a, which is the base, raised to the negative power, which is minus 4. So how do we go about this? Negative index law states that whenever a base is raised to a negative index or power, so a is raised to a negative index, it will be equal to the reciprocal or the inverse of that base raised to the positive form of the power. So the inverse of A is 1 all over A. Now, raised to the positive form of the power. So negative 4 is the power here. So the positive form of negative 4 is 4. You cancel out the negative or the minus, so it becomes 4. Let's take another example. So assuming we have A raised to power negative m, how do you go about this? First of all, you recall the negative index law, which states that whenever a base is raised to a negative index, the base here is A and it is raised to a negative index, so we have minus m. It will be equal to the reciprocal or the inverse of that base. So the reciprocal or the index of A is 1 all over A. And then the base raised to the positive form of the power. Here we have negative power, which is negative m. So if you convert it to a positive form, it becomes positive m. Let's also take another example on negative index law. So assuming we have 2 raised to power negative 2 and we are asked to solve this, how do we go about it? First of all, we recall the negative index law, which states that whenever a base is raised to a negative index or power, it will be equal to the reciprocal or the inverse of that base. Now the inverse of 2, because 2 here is the base, so the inverse of 2 is 1 all over 2. Now it will be equal to the reciprocal or the inverse of that base raised to the positive form of the power. So the base raised to the positive form of the power. We have here negative 2. So negative 2 becomes positive 2. So we have 2 raised to the power 2. Let's take another example. So if we have 7 raised to the power negative 2 and we are asked to solve this, how do you go about it? First of all, you recall your law. Whenever a base is raised to a negative index or power, it will be equal to the reciprocal or the inverse of that base. So let's write the reciprocal or inverse of 7, because 7 here is the base. So we have 1 all over 7. So the reciprocal or inverse of 7 is 1 all over 7. And then the base raised to the positive form of the power. So 7 raised to positive 2. Still on the negative index law, let's solve another critical example. So we have here 1 all over 7 raised to power negative 2. How do we go about it? If you look at this question very well, it is totally different from the ones that we've solved, because we have 1 all over 7 raised to power negative 2. Now the first task or approach is to pick out the denominator. So we have 7 raised to power negative 2. And then let's solve this out. 7 raised to power negative 2, applying the negative index law, would give us 1 all over 7 raised to power 2. Recall, whenever a base is raised to a negative index or power, it will be equal to the reciprocal or the inverse of that base raised to the positive form of the power. So 7 raised to the power negative 2 is similar to the questions that we've solved under negative index law. Now let's call this equation 1. The next task is to substitute this answer into equation 1. So we have here 1 all over 1 all over 7 raised to the power 2. We have here 1 all over 1 divided by 7 raised to the power 2. This can be written as 1 divided by 1 all over 7 raised to the power 2. Now let's invert and multiply. Inverting means you take 1, which is the numerator, you bring it down, and then you take 7 raised to the power 2, which is the denominator, you take it up. So we have 1 multiplied by 7 raised to the power 2 all over 1. 1 multiplied by 7 raised to the power 2 is 7 raised to the power 2. And then 1 multiplied by 1 is 1. So our final answer is 7 raised to the power 2. Now let's look at product power law. Product power law states that to find the power of a product, you can raise each base to the power and then multiply the result. To find the power of a product, you can raise each base to the power and then multiply the result. Let's take an example. If we have a multiplied by b all raised to the power m and we are asked to solve this out, how do you go about it? A multiplied by b all raised to the power m equals, the first task is to raise each base to the power and then multiply the result. We have two bases here. We have a, which is the first base, and b, which is the second base. So now let's raise a to the power. The power here is m. And then multiply both bases. So we have a raised to the power m multiplied by b raised to the power m. Recall, product power law states that to find the power of a product, you can raise each base. We've raised each base to the power and then multiply the result. So we've raised a to power m and b to power m, and now we've multiplied. So a raised to the power m multiplied by b raised to the power m gives us what? It gives us a raised to the power m b raised to the power m. You can leave it this way. You can also leave it this way. Now let's take the final example. If we have 3 multiplied by 2 multiplied by 6 all raised to the power 2, and we are asked to solve this, how do we go about it? First task, raise each base to the power. We have 3 as the first base, 2 as the second base, 6 as the third base. So now let's raise each base to the power. So we have 3 raised to the power 2, 2 raised to the power 2, and 6 raised to the power 2, and then multiply the results. So we add multiplication sign here. 3 raised to the power 2 is 9, multiplied by 2 raised to the power 2 is 4, multiplied by 6 raised to the power 2 is 36. So 9 multiplied by 4 multiplied by 36 gives us what? It gives us 49.